Hello, welcome back. I'm Andreas, your tech-curious web designer. In the last video, we covered the basics of Docker and containerized a simple Django application. In this video, we will containerize a Postgres database so we can easily run it locally, allowing us to work within the same database environment as in production. But before we get started, a quick shout out to my new supporter on Patreon. A high five to Polano. Thank you so much for your support. I really appreciate it. Okay, and now without further ado, let's dive in. In this tutorial, I want to give you a very simple example how to run a Postgres database locally using Docker and connect it to a Django application that doesn't run inside a Docker container. We will pull an official Postgres image from the Docker Hub, create a container and run the container with Docker Compose app. We will open a port on the container and map it to a port on our computer to allow the Django application to connect to our Postgres database. And then we run the application locally in the web browser. Alright, let's get to it. As we don't build a Docker image from our Django app in this tutorial, we don't need a Docker file. So for simplicity reasons, I will just delete the files we created in the previous tutorial, but don't use in this one. I delete the Docker file. And also the docker ignore file. We will, however, use the Docker Compose file. And additionally, I will delete the image and container in the Docker desktop and start from scratch. So I delete the Docker Projects folder, which contains the container, and also the Docker image of the Django app. Okay, let's get started now. So to run a Postgres Docker container, we only need a Docker Compose file. We can give this project a name, but I stick to the same name, my Docker project. But now let's change the service. Instead of Dockerizing the Django app, I Dockerize the Postgres database, and I call the service Postgres. We will use a Postgres image from the Docker Hub. So if Docker doesn't find this image locally, it will automatically pull it from the Docker Hub. This is the official Docker image for Postgres. Here again we have many different image versions available to download. However, I will take just the default image, which gives me the most recent stable release. I will give the container a name, my Postgres container. Then for the ports, Postgres by default uses the port 5432. And I map it to the same port number on the container. Okay, and then we can get rid of the volumes configuration, because Docker by default will create a volume for us. Volumes are important to store and persist data. Without them, we would lose the database data after a restart. We will come back to them a bit later. And finally, we need to define the database credentials to connect to the Django app. And we do that in the environment section. And here we have the 3 environment variables we have to set up. So first we have the database name, and I name it just Postgres. And for simplicity, and because this is just our local Postgres instance, I set the username and password to Postgres as well. Alright, and with that configuration, we can spin up our Docker container now. And see if it's a smooth operation. So in my terminal, I write Docker Compose app. and the D flag for detached mode. Is pulling down the Postgres image from the Docker Hub. But it seems like my container got confused. So the container was created successfully. However, it could not run on port 5432 because that port is already in use. So it seems like I installed a Postgres database manually and it is still running. So we have two options here. We could change our port here, for example, to 33. So we just open a different port on our host machine. Or we find this other Postgres instance and stop it from running to free up the port. I will go with that. So in my terminal, I write sudo, which stands for super user on a Mac or Linux machine. Then lsof, which stands for list open files. These are files which are currently open and running. And -i and then the port number finds the process running on port 5432. And as we can see here, I have a Postgres service running already on that port with the process ID of 320. And to stop this process from running, I write sudo kill 320. Okay, this should be done now. Let's check again. And yes, there is no more process running now on port 5432. Let's run the docker compose command again. And now the container started. Great. Let's have a look in our Docker desktop. As we can see here, it created a Postgres image. This was downloaded from the Docker Hub. And in the container section, we see we have our Postgres container running inside the My Docker project. Nice. Okay, we have now our Postgres database up and running inside a container. Let's connect it now to our Django application. So for this I have to add some configuration to my settings.py file. So I'm going to the core folder, settings.py, and here we have the database configuration. Right now I'm using SQLite 3. Let's change this now to Postgres. So here I'm writing PostgreSQL as our database engine. And for Django to be able to communicate with Postgres, we need to install a driver with the exquisite name psychopg2. Pip install psychopg2-binary. Alright, now this driver is installed and we can continue with the configurations. So the next setting here is the name, and we called our database Postgres. Then we have the user, and the username is again Postgres, as well as the password. Then we need two more settings here. We need to add the host, and here, if we run the Django application without container, our host is the local host. But if we also containerize the Django app, we would add here the name of the service we define in the Docker Compose file, which in this project would be Postgres. And finally, we add here the port, and this is the port of our Postgres container, so 5432. Alright, now we established a connection to our Postgres database inside the Docker container. Let's save this file. This is a brand new database, so we have to do the migrations now. So Python manage.py migrate. Okay, all the tables are now created. Next we add a superuser. Python manage.py create superuser. Alright, superuser is created. And now let's spin up the server. With Python manage.py run server. Alright. Let's check out the website. So I'm going to localhost 1000. And the website is up and running. Let's test the database by logging in. And we're connected to the Dockerized Postgres database. Nice! Let's quickly change also the avatar image. And display name. Alright, we have a smooth operation now, with a containerized Postgres database. So if we leave it like this, the container will stop running when the computer shuts down, and we would need to restart it manually the next time we need it. This is probably the best option if you don't need to run the database all the time and want to free up some CPU resources on your computer. However, we can also add a restart policy to our Docker Compose file, telling Docker to automatically start the container whenever the Docker engine is running. I go to my Docker Compose file, and with this restart option, I'm telling Docker to always restart this container when for some reason it shuts down. This is a good option if you want the container always to run. Another option is unless stopped. This will not restart the container if it was stopped manually, and probably the best option when you are in the midst of developing your application. Alright, and as last, let's quickly address the volumes again. So if we go to the volume section here, we can see Docker by default creates this volume here. This volume stores all the data we put in the database and is decoupled from the container. The Postgres database running inside the container can hold data only temporarily, and without a volume we would lose this data when the container stops running. With volumes, the data is stored independently of the container and persists even after we delete the container with the database. Pretty neat. And instead of having this random string here as the volume name, we can also name it ourselves. Let's see how this is done. So in my Docker Compose file, I add here volumes, and Postgres_data here is the name we call our volume. And the path is the default directory inside the container, where Postgres saves temporarily the database data. So with this mapping, we basically sync the volume outside the container with the files inside the container. And now we also have to define this Postgres data volume. For this, we create a new volume key. This is on the same level as services. And create a volume with the name Postgres data. We could add here more configurations for this volume to control the behavior and properties, but we can leave it just like this to use the default settings. Alright, we can save this file, and because we changed now the container settings and manually defined the volume, we need to delete the old volume and spin up a new container. First, I delete the container. And then the volume. Okay, and now we create a new container with Docker Compose up -d. And as we can see here, also the volume with the name My Docker Project Postgres Data was created. So the My Docker Project is the name of the project itself. And in Docker Desktop, we see the new volume. And the container is up and running. Awesome! As this is a new database, we will need to migrate the tables again. But this is all for this video. Thank you so much for watching. In the next one, we will see how many services can work together with Docker. So we will connect our Django application also with a Redis database, Celery and Flower to create a whole containerized task queue system. I hope to see you there. Until then, stay curious, my friends, and bye bye for now.